Okay, so we will repeat this material and yes, you have to answer on these questions. So what structure is in the middle of the hepatic globule? Easy question. What structure is in the middle of the hepatic globule? Hepatic artery, portal triad, central vein, portal vein, or sinusoids? Oh, sorry. C. Yes, okay. So C is the central vein. The central vein is in the center. Portal triad. The portal vein. The portal vein is the part. Yes, the portal triad. And hepatic artery also is the part of the portal triad. The next question. What is the space between the liver sinusoids and the hepatocytes called? What is the space between the liver sinusoids and the hepatocytes called? Space of disease, space of mole, vacuole, lacuna, or Hauschilt's lacuna? ADC. Okay. So space of DC between the sinusoids and hepatocytes. Space of mole. Do you know what's the space of mole? If you know this, what's the space of mole, you can answer. What's the space of mole? Peritoneal space. Peritoneal. Peritoneal space of mole. It's the space between the hepatocytes here, between the hepatocytes and the connective tissue. This is the space where proceeds usually the lymph formation. Yes, between the connective tissue cells and the hepatocytes. So vacuole, lacuna also Yes, lacuna is associated with the bone cells, and the whole ship's lacuna is the also associated with bone cells or with the osteoclasts. The next question: which structures are part of the portal triad? Portal vein, hepatic artery, central vein, sinusoids, both A and B or both B and C? E and B. I have received two different answers, E and B. What's the E and B? Now, E. E is correct. So the portal vein and hepatic artery. Yes, portal vein and hepatic artery are the parts of the portal triad. And also here are the bile ducts and sometimes lymphatics also. The next question. Which of the following is not a function of the liver? Is not function of the liver. So the metabolism of bilirubin, the amination of amino acids, storage of iron, storage of copper, or storage of calcium. Storage of copper, storage D and storage. Okay, so the D storage of copper. It's not correct answer. You have to find correct answer now.
Calcium, storage of calcium.
Calcium, of course, the calcium storage of calcium, it's the function of bone tissue. Yes, the storage of calcium, not the copper. And okay, so storage of calcium, the correct answer is. The next, what is the functional unit of the liver? What's the functional unit of the liver? Lobule, portal triad, central vein, hepatocyte, or sinusoids? A, the lobule, yes. Yes, so the lobule is the functional unit. I have received also the such answer hepatocytes. Hepatocytes, they are the functional units. The functional unit is the lobule. Hepatocytes are morphological. Yes, the cells, but the functional unit is lobule. Next question. In what structure does blood run through between the hepatocytes? CA. What's the CA? Okay, so again, in what structure does blood run through between the hepatocytes? E, of course, E. Sinusoids, yes, sinusoids are between the hepatocytes. Yes, and then the sinusoids run to the direction the central vein. Yes, the central vein, and then the blood continues to fly. Yes, the sinusoids, then the central vein. What is this space called that's located at the portal canal between the hepatocytes and connective tissue? And I said the answer, yes. Between the hepatocytes and connective tissue. B, yes, correct is B. And you know, the more connective tissue is at the portal area. Then, next question. What layer is not found in the gallbladder? What layer is not found in the gallbladder? Mucosa muscularis, adventitia, serosa. So the function, you know, yes, bile concentration, bile storage. E. serosa, and so yes. Okay, I have received two different answers. Yes, E and B. E is serosa. I showed you. Yes, the gallbladder. Mucosa, of course, is here. The muscular is external, well developed, and adventitious. Serosa, and I said it depends, it's attached to the liver or not. Yes, the part is covered region by the serosa and other part by adventitia, but no muscularis mucosa. B is correct answer. Muscularis mucosa, no muscularis mucosa. Next question. What cell type makes up the mucosa of the gallbladder? Simple squamous epithelium, simple cuboidal, simple columnar epithelium, stratified squamous, or transitional epithelium in gallbladder? C. Simple columnar epithelium. Yes, simple columnar epithelium. In gallbladder, simple columnar epithelium. In bile ducts. Yes, also maybe simple cuboidal or then simple columnar epithelium. The next question. What is the classification of the pancreas? The pancreas is the mixed, is endocrine, exocrine, both endocrine and endocrine, or none of the above. If you remember the pancreas, yes? A. Doctor, what does it mean, Mariam? Doctor, the pancreas is doctor. Okay, so the pancreas. I've received the answer mixed. Sometimes in some literature also the pancreas is written such as the mixed, but really it's the both endocrine and exocrine. Mixed sometimes, for example, the cells, hepatocytes, they have the
რაღაცას ვთქვათ შეიძლება?
E.
ანუ რა განსხვავება, ანუ ორივესა და ანუ both რო ეწერა და mixed
აი,
შორის?
ამას ახსნი ამ წუთში. ხო, Mariam, ეხლა ახსნი. აი, mixed. For example, these hepatocytes, they have mixed function. Exocrine and endocrine function because they are the same, yes, cells, and they have the both function together. But the pancreas, the part of the pancreas is exocrine and the part of the pancreas, but they are the different, yes, the parts and different cells. And they have endocrine function because more correct is the both. They have endocrine and exocrine. But sometimes we also use the terms that is the mixed. I only want to say this because it's not very correct, because in some books are mixed, in some books are the both endocrine and exocrine. But the difference is when the same cell has the both function together, and the pancreas is something, the combination of two parts. Yes, the endocrine and exocrine function. It's not such the mix, it's both endocrine and exocrine. Yes. Then, which cell is a hepatic macrophage? Which cell is a hepatic macrophage? Kupffer cell, histiocyte, dust cell, Langerhans cells, or microglia? Of course, you know the answer. Yes. A. Yes. The Kupffer cells are the microphages. Yes, the specific microphages of the liver and the function. Yeah. So where we can find these cells? So within the sinusoid lining, and the function of these cells, they recognize and the phagocytose aged erythrocytes, and are also antigen presenting cells. They can remove any bacteria. So typical macrophages are the Kupffer cells. And sometimes the Kupffer cells also they are involved in freeing heme and iron for reuse, and for storage and for reuse also. And so the Kupffer cells are the liver macrophages. The histiocytes are the macrophages of connective, yes, tissue. Dust cells, if you remember, dust cells are macrophages in alveoli. Langerhans cells, yes, in the skin are also the macrophages, the microglia in nervous tissue, you know. And the next questions: what is where in the pancreas are islands of Langerhans most numerous? In head, body, tail, depends on the individual. C. Yes, it's correct. C. In tail region, most numerous are the cells, islands of the endocrine cells. The next question: what structure is the angle of the liver lobule? This answer knows everyone. Try it. Okay, the liver lobule at the angle is the portal triad. B, it's correct. The next question: what of the following is not a function of the liver? Again, what is not the function of liver?
A.
A. Yes. So cholecystokinin production is not function of liver, it's function of small intestine. Yes, it's function of duodenum. The next, which of the following is not a function of the liver? Again, this same question. Conversion of glucose into glycogen, storage of glycogen, storage of bile, storage of fat-soluble vitamins, cholesterol synthesis, which is not function of liver.
C.
Yes, C. Storage of bile, it's not function of liver, it's function of gallbladder. Okay, now which of the following statements regarding the three zones, and you remember, yes, three zones where it's the liver, the acinus, yes, and the three zones comprising the liver acinus is correct? Which one is correct? Zone for the first is closest to the central vein. Zone 2, the second zone is the first to undergo necrosis of circulation if circulation is impaired. The zone 3 is closest to branches of the hepatic artery. Zone 1 is the first to receive nutrients delivered by the portal vein, and zone 2 is the last to receive any toxin that may be in the blood. D, 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 D. Zone 1 is the first to receive nutrients delivered by the portal vein. Yes, it's correct answer. It's correct answer. D is correct answer. Next, this region of the GI tract. What is this? This is lower esophagus, cardio of stomach, pylorus of stomach, duodenum, gallbladder, jejunum, appendix, or colon. This one. Jejunum, gallbladder, jejunum. No, it's not jejunum. It's gallbladder. It's gallbladder. So, if you remember jejunum, numerous folds are, yes, numerous folds, well-developed folds, and it's gallbladder. Next, so what is indicated here? The asterisk is in liver sinusoid, space of disease, central vein, branch of hepatic artery, bile duct. Of course, it's not the pancreas, yes, into the center. C, of course, is the central vein. Yes, into the center is the central vein. Next, so this tissue, what's this tissue, and what we can see in this micrograph? Liver, yes. So liver tissue, I think you can understand if I'll show you the liver tissue, it's clear, yes? Multi-lobal structure is here. Then, now, liver, yes, Hepatocytes, yes, hepatocytes, these large cells, and I showed these granules, brown, yellow, these granules, lipofuscin granules in long living cells, when usually are these granules. And the liver cells are long living cells, but if you remember, liver has very important function also, and liver has capacity for regeneration. Yes, it's very important, the function of the liver, specific function, not salivary glands, not the pancreas can regenerate. Liver has such capacity regeneration, and from the part when hepatocytes lost from the action of toxic the substances triggers mitosis in the remaining healthy hepatocytes in a process of compensatory hyperplasia that maintains the original tissue mass. Yes, and from the part of the liver then can regenerate and the whole the normally functioning liver. Then what we can see in this microgram. Triad, yes, the triad. And in this triad, yes, we can distinguish these branch of artery, yes, branch of vein, and also bile ducts. And yes, about the regeneration, also, if you remember, are another cells, the stem cells. Yes, the like stem cells are the oval cells between the cholangiocytes of the bile ducts, but these cells are not so important. These cells, yes, the stem cells, they in experiments from these cells forms the new tissue, but usually they are not very important, these stem cells, compared to the capacity of the liver. The hepatocytes can regenerate yourself. Then okay, this portal duct, central vein, portal duct. Okay. Now, yes, this is the central vein, portal triad. Really, this is the lobule. Yes, this is really the lobule, hexagonal structure, lobule, central vein with the triads at the periphery. Okay, now what's this? Gallbladder. Yes, it's gallbladder. Okay. Mm, yes, you thought that like these answers I received that jejunum. Yes, here, look carefully. This is the external, yes, the part. If you remember, in small intestine are the folds. Here also you can see the folds, but then muscularis, Yes, this is the muscularis, and very thick is, yes, this part. In small intestine, the external layer is serosa, thin serosa. Yes, and here is so thick. This part is also the serosa, but this part then is adventitia, more thicker compared which is in small intestine. Yes, you can see the connective tissue, thick connective tissue, something thick like the muscularis. Yes, this same thicker they are. Okay, this is from again from this gallbladder. And what is this part? Mucosa. Yes, this is the mucosa with epithelial lining and lamina propria. In lamina propria, you can see the lymphocytes. Yes, the blue stain, the nucleus, they have lymphocytes. And here you can see the bands of the smooth muscles. Smooth muscles fibers are here, smooth muscle fibers. Then this, sorry, this is epithelia. Yes, again, epithelial lining of mucosa of gallbladder. Folds. How you think this gallbladder is empty or filled? Of course it's empty. Yes, because all these folds are when gallbladder is empty. Now this question. I'll show more high magnification of this question. Hepatocytes. D, E, hepatocytes. So, not sinus. Yes, the hepatocytes. This is the reason of damages of hepatocytes, the main cells of the liver tissue. Okay, so the Kupffer cells, again, I want to say something about the cells, the other cells of the liver. So the hepatocytes is clear the function of these cells. The Kupffer cells are the macrophages, yes, of the liver, and are involved in removal of the erythrocytes and the other debris, and reuse the iron also. And another type, yes, the Ito cells. Again, what's the function of the Ito cells? The function of the Ito cells, small cells with lipid droplets, yes, inside the cytoplasm of this, and I said it's very difficult to find in micrographs, these cells. They are small cells and the less numerous, and they are in sinusoidal spaces. Yes, in sinusoidal lining are also the Kupffer cells located, and the Ito cells are in perisinusoidal spaces, ethel cells in perisinusoidal spaces, and small cells with lipid droplets, they are involved in storage of vitamin A, and also sometimes they regulate activity of Kupffer cells. And they also secrete extracellular matrix components. Yes, the ethel cells. So ethel cells influence on Kupffer cells activity. Kupffer cells are macrophages. Okay, the next question. I don't know. I have received or yes, I have received the correct answer that the sodium, yes, the sodium is reabsorbed by, okay, A, correct answer is A. So the sodium, the pumps, usually the sodium pumps are involved in cholangiocytes, water absorption and water secretion. Yes, so the correct answer is this, the sodium ions.
Sorry, doctor. What about the hydrocarbonate? I know sodium is there, but because this is inflammation as well. What about the hydrocarbonate?
What about other? This?
What about the hydrocarbonate?
Please, can you send me the question because I cannot. Can you send me the questions? Sorry. Okay. Ah, yes. Bicarbonate, yes. No. So in this, so this is about the cholangiocytes. Yes, this is the cholangiocytes, and cholangiocytes, here in cholangiocytes are the numerals, the sodium, the pumps, and these sodium pumps are involved in activity of these cells, not the bicarbonate ions, which are in another type of ducts. Yes, which we studied during the other parts of this digestive system, not these. The sodium pumps are not these. If you want, you
Why
can
not?
send.
May I ask something?
Yes.
So I'm interested in why exactly the sodium ions, not, for example, calcium, because there was written that she or he had joint problems also.
Yes, but so these cholangiocytes, so the concentration of the bile, yes, the and water absorption, water reabsorption. Okay, I'll show again this. Okay, the mechanism of this activity is the includes the sodium pumps. This is the into the in membrane, yes, of these cells. The sodium, the pumps are here, and then these pumps are involved in this, not the bicarbonate ions. So bicarbonate ions movement proceeds, yes, and here these sodiums are really the pumps located into the membranes. This is about the pumps, not the bicarbonate ion, the movements.
Dr. Tamar, I mean
Yeah.
calcium ions, not bicarbonate ions.
These are these ions, calcium ions.
Yes, because there was written that we had joint problems. So, as we know, joint problems also maybe is caused by this calcium ions, something changing the pump. I don't know.
Yes, it depends, of course. Calcium pumps also, but it depends on the structure. Yes, it depends on the membrane structures. It depends on the cell types, which ions are the most numerous. And here in these cells are these ions. So in these membranes, we have different pumps. Yes, but in these cells
So,
are,
so
yeah.
we are interested in the numerous ones. So
Yes,
we
yes.
can, yes. So in other situations, maybe we can also
Yes,
click
it
on other
depends.
numbers.
Yes,
Yeah.
because it depends on the membrane structure. In different the membranes are the different pumps. Yes, are involved are the most numerous. In here in cholangiocytes are these pumps, which are active pumps here, not the pumps and the ions, the channels, other channels. Yes, with the calcium channels we also know, but these are about the cholangiocytes.
Okay, thanks a lot. Thanks a lot.
Yes, if you have any questions, yes. I don't know, is it understandable or not? It depends on the region and it depends on the cell types, it depends on the membrane. And this, I think this is the last question. Yes, for today. Okay. B. Yes, of course, the answer is B, glycogen granules, which are numerous in hepatocytes. And if you remember these zymogen granules, where we can find these granules? Zymogen granules, where we can find these granules? If you remember. Yes, the correct answer in pancreas. Yes. Okay, so it's in pancreas. The zymogen granules are in pancreas. And how you think, are numerous ribosomes or not in hepatocytes? About ribosomes. What's the question? Question is, what about the ribosomes? Are many, how you think, are many ribosomes or not in hepatocytes? Yes, of course, there are many, and especially, and also I have such the question: these ribosomes are free ribosomes or associated with endoplasmic reticulum? Yes, there are endoplasmic reticulum, and if you no, when this cell is exocrine cells proceed something secretion, and these cells usually contains the numerous ribosomes, but these ribosomes are located on endoplasmic, yes, reticulum. Okay, I think that was the last question. If you again any questions, you can send me uh, questions if you are interested in something. Okay, thank you. See you. I don't know, see you or meet you in next week. Goodbye.